Hi, in this video, we're going to take a look at our muscles at the microscopic level and see how it contracts and relaxes. Our arms can do a lot of things. It lifts, it pulls, and it rides. It can even skate. Let's take a closer look at our muscles. What appears in front of us are long fibrous fibers that constitute our arms. If we zoom in even more, we will arrive at the smallest functional unit of muscles, the sarcomeres. Sarcomeres are long fibrous proteins that slide past each other when muscles relax or contract, defined by the segments between the two Z lines. When we want our muscles to contract, our brain sends some chemical signals called acetylcholine through the motor neurons to our muscle cells, which leads to the creation of a muscle bridge between T-tubule, an extension of muscle membranes, and sarcoplasmic reticulums. We can think of sarcoplasmic reticulum as an organelle that stores the calcium ions. Upon receiving the chemical signals from the brain to contract our muscles, sarcoplasmic reticulum spits out calcium ions in it, causing the calcium levels in our cells to increase. And when not signaled, the sarcoplasmic reticulum sucks in the calcium ions, causing the calcium levels in our cells to decrease. Now, why do we care about our muscles' intracellular calcium level? This brings us back to sarcomeres again. This time, we look at a single pair of the sliding filaments. On top is the thin filament actin. On bottom is the thick filament myosin. Let's look at actin first. There are two proteins on actin. First, the long fibrous one is called the tropomyosin, which coils around the actin. At normal low calcium level, it covers myosin's binding spots, disallowing it to attach to actin. Second, the nail-looking protein is called troponin, which pins tropomyosin to actin. When calcium level goes up, conformation changes causes troponin to move the tropomyosin away from myosin's binding spots, allowing myosin to attach to the actin. Finally, let's talk about myosin. Myosin is a kind of ATPase whose reaction cycle with ATP causes the power stroke and move the actin relatively. The reaction sequence begins with myosin's head bound to an actin subunit. Next, ATPs will bind to myosin's head, causing the myosin to detach from actin. Then, hydrolysis of ATP to ATP and phosphate triggers a conformational change that rotates the myosin lever and reattaches myosin onto the actin. As the reaction products exit, the myosin lever returns to its original position, which causes the thin filament to move relatively to the thick filament, completing the power stroke. And of course, when myosin's binding spots are covered by tropomyosin, myosin will not be able to move the actin, causing the muscles to relax. And that's how our muscles work.